I want to talk about gambling and random walk theory. Okay, so let's get this straight. A random walk is a walk on a lattice structure. A lattice structure, it's best to talk about in two-dimensional space. It's just the integer values, where both the x coordinate and the y coordinate in two-dimensional space is integer valued. So a lattice structure would be like the origin 1, 1, 2, 2, 5, 7, -3, -20, just, integer values. So no decimals, no fractions, all that jazz, right? Just integer values. So you're just walking along these integers. And essentially, so in every direction, you have equal probability. So in two-dimensional space, you have two-dimensional space, you have equal probability going up, down, left, and right. So it's 1/4 probability. And you just keep doing this process forever. And so, both in one and two-dimensional space, these processes, these random walks, are recurrent. So that means they're going to visit every point in one and two-dimensional space infinitely often, right? With probability 1. So good. And in three-dimensional space, it's transient, which means there's positive probability it's never going to come back to the same place. So what they say, right, what mathematicians say, is that if you have a drunk guy who's lost, right, because he lives in two-dimensional space, his houses, and stuff are in two-dimensional. A drunk person will always find his way home if he just randomly walks randomly all over the place. It's just he'll always find his way home because he has to. If he just randomly goes, eventually he'll find every home. Literally, he'll find your home too. Joking, but like really. But a drunk bird will never find its way back to where it started because it's three-dimensional. Yeah, so it's, and assuming again the bird, it just flies within a lattice structure, which isn't real, but it's like the joke of all jokes. So why am I talking about this? This concept relates to gambling, right? How does it relate to gambling? First of all, it's when I talk about gambling and random walk theory, I'm talking about one-dimensional space. So I'm just talking about a line, right? And it wouldn't even be a real number line. It would just be the integers, essentially 0, 1, -1, 2, -2, 3, -3, all this stuff. And if you win money, you move to the right. If you win, it's $1 or $10 or $100. I just don't care. But if you win whatever, unit of measure, if it's $1, that's fine. If it's $1,000,000, right? I mean, they do this stuff. Some people bet millions of dollars. You just move to the right. And if you lose like $1 or $1,000,000, you move to the left, right? And so this is really cool because according to random walk theory, you're going to win because as you go to the right, you're going to win as much money as you could ever dream of and more, right? Let's say you want to win $10 billion. According to random walk theory, eventually you'll be way past 10 billion. You'll be past 10 trillion. You'll be past 10, whatever, quadrillion. I don't even know if they have that much money in the world, but according to the theory, that's what you'll win. And the same is true about what you're going to lose. It's a two-way street. You know what I mean? It's not like you just win, win, win. No, you're going to win as much as you could ever imagine. You're going to lose actually more than you could ever dream of. It's a two-way street. And so, and the same logic applies both for, the player and the casino. The problem herein, first of all, there's a little positive drift. It's not because I actually said a random walk is 50-50 going, or, equal probability going any direction. So in one-dimensional space, it would be 50-50, go either way. It's not quite 50-50. I think generally the house has a slightly better probability in almost every casino game. That's what I believe. I'm not an expert at casino games, but I believe that that's what casinos do. They rig the system. So they have to. That's their job, right? Anyway, so no big deal. So that's number one, but it doesn't matter because according to random walk theory, it's still, it's still recurrent. You're going to win as much money as you could ever dream of, and you're going to lose as much money as you could ever imagine, and then some. But there's going to be a little bit of drift, in the one direction where you're going to lose because the probability is better that, for the house than the player. No big deal, but you're still going to win crazy amounts of money, more than you could ever imagine. Okay, so it sounds good to me. So right now I'm thinking, hey, I want to win more money I can imagine. So I'm going to go gambling. Let's go do it. Let's do this gambling thing. There's a problem. In order to do this, in order to gamble and win as much money as you want, you have to be able to handle losses, because when you lose all the money, you're done playing. And that's a problem. That's the problem. People generally have a very finite amount of money, and this drift is going to go every which direction. You're going to win crazy money, and then you're going to lose crazy money, and it's going to go both ways. No worries. The problem is when you go far enough to losing, you're done playing, and so you can't ever realize this phenomenal wins. That's a problem, and it's a problem for players, and it's not. It's actually a problem for the house. When I say the house, I mean the casino is called the house. It's a problem for the house because they also have a finite amount of money. But let's get real, their finite amount of money just dwarfs in comparison to every individual player. I mean, I would actually say that I think the casinos have nearly unlimited financial potential. And I say this because they make their own chips, and these chips are representing the money that, so they're kind of printing money in a backdoor manner, right? They're the ones that give value to these chips. Anyway, so random walk theory kind of explains that gambling might not be a good thing unless you have a phenomenal amount of money. And even then, it's probably not a good idea because on top of having a phenomenal amount of money, you want to be the house. You want to have so much more money than your opponent that eventually the random walk theory will take all their funds, right? And so on top of the individual probabilities that drift towards the house, the casinos, you have the entire concept of random walk theory, which essentially is going to bankrupt an individual way before they bankrupt a casino. I don't know if they've ever bankrupted a casino yet, but I don't know about that. And the logical conclusion, how can you circumvent this dynamic? Well, I think if players grouped all their money together and worked as one, they could create this house, this casino kind of thing to share, proceeds. But I think people generally don't do things like that. I think there's enough legal trust and all kinds of humans don't do that kind of stuff. So it'd be a logical conclusion that would work better than everybody individually playing a game cleaned out on their own. Pulling the money together will allow a better probability that you can get more positive drift, you know what I mean, for long, because you can play longer. But I just don't think that's a human characteristic that people do, to be completely honest with you. All right, thank you for watching. Appreciate it.